Although we customarily label the contemporary phase of the planet as the age dominated by mammals, it might be more accurate to describe it as the age of insects, considering their vast population. While the human race boasts over 7 billion individuals, the number of insects is staggeringly greater, reaching the mark of 10 quintillion. We commonly perceive ourselves as preeminent beings due to our ability to enact laws and our relatively large physical stature. However, there was an era, about 315 million years ago, when insects not only proliferated en masse but also reached gigantic proportions. Rewinding to the time of the Carboniferous period, between 298 to 358 million years ago, we would encounter the Meganeura, a massive precursor to modern dragonflies, whose wingspan reached 70 centimeters, equivalent to the size of a pigeon and 3 times larger than the dragonflies we know today. The Stephanodopus, though more modest in size, still boasted an impressive wingspan of about 40 centimeters, akin to that of a thrush. And it wasn't only the insects that were remarkable for their colossal size, other forms of arthropods also shared this feature, as is the case with the Arthropleura. Think of the centipedes that lurk beneath decaying wood in the forests, and now imagine them at up to 2 meters in length and half a meter wide, roaming the forest floor like a living cloak among the foliage. But why did these invertebrates attain such extraordinary dimensions? The answer lies in the level of oxygen available in the atmosphere. Today, the air contains approximately 21% oxygen. During the Carboniferous, this value was significantly higher, approaching 35%, due to the exuberant growth of vegetation that covered vast areas of the globe, consuming carbon dioxide and releasing oxygen in copious amounts. In contrast to the past, nowadays organic matter such as wood is decomposed by microorganisms, a process that reduces the amount of oxygen and increases that of carbon dioxide in the atmosphere. However, during the Carboniferous, the lack of microorganisms specialized in decomposing plant matter meant that oxygen was not only produced on a large scale but also remained in the atmosphere. This superabundance of oxygen was a determining factor for the growth of arthropods, whose respiratory system comprised of spiracles and tracheae directly depends on the concentration of oxygen in the environment to define their maximum size. At that time, the oxygen-rich atmosphere facilitated the supply of this vital gas, allowing them to reach dimensions never seen since. Recent studies, conducted by scientists in controlled environments like at Arizona State University, have shown that arthropods exposed to high levels of oxygen grow considerably in size over generations, supporting the theory that the Carboniferous environment was fertile ground for the growth of these giant creatures. Indeed, there is a proverb that preaches, "Excess is a burden." Inspired by such wisdom, scholars have advanced another line of thought: the oversized stature of arthropods may have been an evolutionary imposition, not merely a choice. While abundant oxygen might benefit adult arthropods, for the young forms, this same excess oxygen posed a lethal risk. The larvae, unlike the adult specimens, did not have the capacity to regulate oxygen intake, and the surplus could be deadly. Faced with this dilemma, researchers from Michigan State University proposed that ancestral larvae grew in size to reduce the ratio of oxygen absorbed per unit of body mass, resulting in larger adults. However, constancy is not a trait of the natural narrative. About 275 million years ago, during the Permian, Earth underwent drastic changes. The levels of oxygen in the atmosphere dropped, the causes of which are partially nebulous, although they may be linked to climatic variations. Such changes warmed the hearts of continents and promoted the contraction of the great swamps, which served as large carbon reservoirs and sources of oxygen. Moreover, decomposer organisms emerged with the ability to process the accumulating dead wood. The activity of these beings further decreased the concentration of atmospheric oxygen, releasing more carbon dioxide. With the dwindling supply of oxygen, the existence of the colossal arthropods became unsustainable. Journeying further ahead in time, around 305 million years ago, the immense Arthropleura vanished from the forests. And moving forward to 299 million years ago, the last flight of the Grand Meganeura was witnessed. The descendants of these giants never reached the intimidating dimensions of their ancestors. Nevertheless, this apparent evolutionary setback did not spell the end. In fact, it was a new beginning. Today, the myriad of insects, arachnids, and other terrestrial arthropods dominate in terms of biomass and species diversity. And although the heyday of these beings might be attributed to the Carboniferous, when they reached their peak of expansion, they still maintain their supremacy in the realm of adaptability.